Thanks so much for having me. My name is Ryan Foxwell. I'm a master's student in mechanical engineering at the University of Victoria, and I'm working on the Solid Carbon project. If you could go to the next slide, please. So Solid Carbon is developing an offshore negative emissions technology known as a NET that aims to turn carbon dioxide into rock by injecting it into the ocean's subsea floor basalt, where it will mineralize and remain permanently stored. This net aims to put CO2 back where it belongs. Next slide, please. So why are nets important? This graph, which I'm sure many of you have seen before, shows the projected global CO2 emissions over the next century or so, with the business as usual case, as well as the pathways to 1.5 and 2 degrees warming. The IPCC predicts that to limit warming to 2 degrees Celsius, net zero emissions need to be reached somewhere around the end of the century, and by about 2050 in order to limit it to 1.5 degrees. Beyond that, net negative emissions will actually be required, putting back more CO2 than we emit. So how do we get there? First and foremost, a large chunk must be mitigated using conventional techniques such as adoption of renewable energy sources, electrification, and reducing consumption. The remaining emissions shown in blue will likely need to be removed from the atmosphere, addressing the hard to abate sectors and historic emissions. Recent studies have found the need to remove approximately 10 gigatons by the mid-century, nearly 20 gigatons by century's end. To put this into perspective, 10 gigatons of CO2 is equivalent to roughly the emissions of 2.1 billion cars, or 1.5 times the number of cars worldwide. Next slide, please. So how will Solid Carbon address this issue? Well, it's basically divided into 3 steps. First, renewable energy will be used to drive carbon capture technology, pulling CO2 from the atmosphere into a pure stream of CO2. Second, the CO2 will be injected deep below the ocean floor, roughly 2,700 meters deep, into the basalt rock formations, where third, it will mineralize with the basalt to form solid rock in a short time span and remain there permanently. Next slide, please. So the project is broken down into 3 main activities: engineering, geoscience, and public and investor acceptance. Collaboration across many institutions is taking place for this. So the engineering team led by UVic, which is the team I'm a part of, is building the systems models to analyze the trade-offs for using different technologies. Some of these technologies we'll assess include floating offshore wind, direct air capture, platform designs, as well as pumping and drilling techniques for CO2 injection. We will complete techno-economic assessments as well as life cycle assessments to understand the CO2 removal potential. The geoscience team from UVic, University of Calgary, and Columbia University are working to model the CO2 injection in basalt and conduct a field study in the Cascadia Basin by the end of the 4-year project duration. The public and investor acceptance team from UVic, UBC, and Columbia University will be conducting surveys to address the largest issues surrounding space, such as do nets enable continued use of fossil fuels? And MBA students will be working in teams to analyze and develop business cases for this. Additionally, the legal framework surrounding injection is to be explored. Next slide, please. So what must we do? We must do our best and remove the rest. Thanks so much for listening.